I love it out there. And so, I'm actually struggling with what do I do? Um, it is hard for me to think about just walking away because it is a great community. It is so much more to me, certainly, than just a piece of property. Um, but at some point, you have to think, what's the definition of craziness? If I just keep pouring money into it and nothing changes, you have to make some hard decisions. And I think, unfortunately, there are a lot of property owners right now that are faced with some very difficult decisions.
Good morning, Professor Siriani. My name is Joe Ayatona, and I would like to speak with you today about shoreline protection and how it can be implemented to guard against the staggering effects of erosion along the shoreline that surrounds Windsor and Essex County. As you just saw in the prior video, the 165-kilometer shoreline that surrounds our region is under attack. Windsor and Essex County is surrounded by three bodies of water: Lake Erie, Lake St. Clair, and the Detroit River. Since its inception in 1973, the Essex Region Conservation Authority, also referred to as IRCA, has been empowered through the Conservation Authorities Act of 1946 to further the conservation, restoration, development, and management of natural resources within the area of its jurisdiction. IRCA's jurisdiction spans approximately 1,681 square kilometers across 9 municipalities, over 4,200 acres of natural lands, and is surrounded by the 165 kilometers of shoreline that is the focus of this presentation. Shoreline protection is classified as a conservation issue because it reduces or prevents the rate at which a land surrounded by water erodes. IRCA design parameters outline that any shoreline protection measure must be designed to slow or arrest the erosion rate such that it does not encroach on a structure's building envelope for 100 years. A study was completed in 1976 by Dillon Consulting that defined the shoreline erosion rates for this region. Windsor-Essex County was split up into segments along the shoreline and investigated individually to determine each segment's rate of erosion. These erosion or recession rates are still used today in designing the appropriate shoreline protection methods. There are three main factors that affect regional shoreline erosion: variations in water levels, waves, and the physical composition of the shoreline. Water levels around the world are rising at an alarming rate. When examining these charts provided by the Ministry of the Environment, you can see that the monthly mean water levels of the Great Lakes fluctuate by more than zero point 0.5 meters in Lake Erie and zero point 0.4 meters in Lake St. Clair. These fluctuations change the location of erosion along the shoreline and can be considered as a primary cause of shoreline erosion. Waves are a result of winds creating friction along the water's surface and are the most direct form of shoreline erosion as they are constantly breaking down and reforming the natural shoreline. Wave height is a function of water depth, duration of wind, and the continuous water area at which the wind blows, commonly known as fetch. As you can see in this figure, it shows that the greater area or distance over which the wind has to blow, the more time a wave has to build or propagate. Since Lake Erie and Lake St. Clair both have enough surface area and length to facilitate fetch, it can be directly related to wave heights and should be considered when designing shoreline protection. Given that the Detroit River is as narrow as 0.8 kilometers and 4 kilometers wide at parts, fetch does not play a crucial role in wave height and development. Scour can be defined as the removal of the granular waterbed material from downward spiraling hydrodynamic wave forces. Scour is a type of erosion that occurs when a wave encounters a shoreline or coastal structure and its refraction tumbles forward in a swirling motion towards the base of the system, more commonly known as the toe. This turbulent action dislodges granular material along the bottom of the structure and over time will undermine the structural integrity and cause failure. Overtopping can be defined as the volume of wave discharge pushed over the crest of a break wall. As the water rushes over top of the wall, wave energy is not entirely dissipated and can contribute to a shoreline's recession rate. Most cases of wave runup and overtopping are a direct result of a storm surge. As you can see here, a wave deflector has been installed to guard against overtopping and redirects most of the wave's energy back into the lake. Also, a concrete splash apron is commonly installed to reduce the erosive effects of overtopping on the landside soil. The land along the Windsor-Essex County shoreline is composed of glacial soils. These glacial soils are composed of many different soil types, with the most common types being clays, clay loams, sandy loams, and sands. When considering the erosion of a specific shoreline composition, it must be noted that particular soil composition and shoreline characteristics can either increase or reduce the erosion rate due to wave energy. Along the sandy beaches of Point Pelee, the erosion or recession rate would be much lower than that of a steep slope shoreline or bluff, because the waves will break and exert their energy before they reach the shoreline. Along the Detroit River, the shoreline is much steeper, but not as wide as Lake Erie or Lake St. Clair. These geographical features create a different type of erosion due to the lack of fetch. The shoreline's erosion along the Detroit River is primarily due to river currents and waves generated by passing boats. Although there are many direct and indirect objectives of shoreline protection, the main objective that IRCA has outlined in their design criteria is to implement all necessary measures to protect a structure's building envelope from 100 years of erosion. For example, this figure illustrates a simulated scenario of an unprotected shoreline along the Detroit River and how the property's recession rate will affect any shoreline protection measure. Since IRCA requires any new construction or extensive renovation to be constructed such that the 100-year erosion line does not infringe on the structure's building envelope. As the figure shows, the property line indicates that its parcel dimensions are 100 feet deep by 50 feet wide. A proposed 25 by 40-foot building envelope will be set back from Riverside Drive. The rear of the structure is approximately 54 feet from the shoreline. When applying the yearly erosion rate for the Riverdale segment, 1.15 feet per year, without any shoreline protection, the erosion line ends up in the middle of Riverside Drive, 115 feet from the shoreline. After a brief analysis, this property will require shoreline protection. Many types of shoreline protection can be constructed to prevent and decelerate the effects of erosion effectively. It is essential to include that this presentation will only identify the most common regional shoreline protection types applicable to this region. These protection types are artificial beach foreshores, revetment walls, and steel sheet pile retaining walls. Also referred to as breakwalls, seawalls, or bulkheads, sheet pile retaining walls are constructed of corrugated metal sections that are connected together and pounded or vibrated into the waterbed. Sheet pile retaining walls are designed as cantilever walls that garner their strength from their embedment into the waterbed. Depending on the characteristics of the shoreline, tieback anchors are almost always connected landward to secondary anchor walls. This combination of embedment and tension gives the sheet piling its vertical stability and resistance to erosion. A sheet pile retaining wall is the most expensive of the shoreline protection methods and costs approximately $500 to $700 per linear foot to install. The installation of an impermeable steel pile retaining wall creates a poor aquatic habitat for fish and often necessitates approval from the Department of Fisheries and Oceans Canada and a plan to offset the impact that the wall has on the habitat of the fish, frogs, and other aquatic organisms disturbed by the construction. Revetment walls are generally comprised of a layer of impervious material affixed to the shoreline slopes or embankments to protect the area from wave runup and erosion. The construction costs associated with the assembly of a revetment wall are much less than that of a steel sheet pile retaining wall. Revetments are naturally less complicated to install and are relatively easy to maintain. The average material costs associated with constructing a revetment wall can range from 100 to 550 per linear foot. A revetment wall will positively impact the aquatic habitat along the shoreline where it is constructed because of its natural sloping conditions. Artificial beach foreshores can occur naturally or be artificially constructed of cobblestone or gravel. Many beach foreshores exist within the Windsor-Essex County region and present an effective, natural shoreline protection method. The average price of materials to construct an artificial beach foreshore in the Windsor-Essex County region is between $95 and $155 per linear foot. Maintenance-related costs associated with an artificial beach foreshore should also be noted, as they may have to be replenished periodically due to the dynamic nature of the material's reduced size. An artificial beach foreshore will have a positive environmental impact due to the long-term improvements it provides fish and other aquatic organisms along the shoreline because of its natural composition and no need for additional artificial elements to render it an effective shoreline protection method. In conclusion, the effects of shoreline erosion are very real and directly affect the region's ability to sustainably develop along the water that surrounds Windsor and Essex County. When constructing a new building or making significant renovations to a structure along the shoreline in Windsor-Essex County, it is required to follow and meet the criteria set out in IRCA's design requirements. Always contact a licensed shoreline engineer to design an appropriate protection method that can prevent and decelerate the effects of shoreline erosion and flooding. Professor Siriani, thank you very much for your time. I thoroughly enjoyed researching this topic and undoubtedly will use this information to further my career. Let's open up the floor to any questions you might have.